Thank you for choosing Sinovision products. Today I will introduce the function and the operation of the three-dimensional reformatting plugin, also referred to as the 3D. The plugin is included as one of the advanced applications in Sinovision's IVW Workstation. It mainly contains the volume rendering technique VRT and the shaded surface display SSD technology. Volume rendering technique, also known as VR, is to reformat the thin layer exam data three-dimensionally and generate colorful stereo images. The color rendering in this software is vivid, according to the needs and operator preferences. The colors can be edited and configured. The anatomical structures are rendered three-dimensionally and intuitively, which helps to avoid the trouble of using 2D images to imagine three-dimensional space. It assists clinicians to locate quickly and accurately and make the diagnosis. Now let me demonstrate the operation process of this plugin. First, left-click to select the patient from the patient list. Then in the series list below, select the thin layer and soft tissue kernel series. Right-click to open the drop-down menu and select the Add Process button. Select the 3D button, or in the lower right corner of the screen, open the function switching panel and click the 3D button, entering the 3D interface. We can see the view area on the left and the function operation panel area on the right, which is divided into via images on the left, axial, coronal, and sagittal images on the right. You can also switch the layout as needed. The function operation panel is mainly divided into two areas: the general function area and the 3D dedicated function panel area. The patient name row above the general tool at the top displays the loaded data information. Click the arrow to unfold or fold the loaded data information. In the drop-down menu, we can switch to other patients, switch image series, or delete studies. The eye symbol is displayed in the lower left corner of the series thumbnail, which indicates the currently displayed image series. Double-click or drag the thumbnail to switch the images on the display. The upper left corner is the series number. The lower right corner is the image number. Click Clear behind the patient name in the drop-down menu to clear the selected patient. Click Clear All to clear all the loaded patient information in the drop-down menu. It should be noted here that after clearing the related report film, 2D images are cleared. The function buttons in the lower part from left to right are default operation. After selecting, the left mouse button in the VIA view area is rotation function, and in MPA view area is page turning function. Pan. After selecting, we can pan the image position by holding down the left mouse button. Zoom. After selecting, hold down the left mouse button and drag it up and down to zoom in or zoom out the image. Adjust W or L. After selecting, hold down the left mouse button and drag to adjust window width and window level. 2D Quick View. After selecting, a quick browsing dialog box will pop up on the interface. We can directly browse the axial images without switching to the 2D display interface, and can also perform measurement annotations, adjust window width and window level, etc. Here we focus on the bookmark function. In our daily work, we often encounter that the image has not done processing yet, but there is another urgent task that should be completed immediately. The bookmark function can save the current processing states, so that we can continue processing the image next time. The 5 buttons at the bottom from left to right are Reset. After clicking, the image return to the initial state, which means to restore the image processing result to the state when just loaded into the 3D interface. Send to film. After clicking, the selected images will be sent to film layout. Send to report. After clicking, the selected images will be sent to the report layout. For the report editing, save. After clicking, we can save the selected images as DICOM images or screenshots to the database or local disk. Tools. Click to open the tool interface with measurement annotating, screen recording and rotation, where rotation can save 3D images in batches. The above is the introduction of general tools. And in other post-processing plugins, there are the same general tools. Their function and operations are the same. Now, I will take the chest as an example. Demonstrate how to extract bones and lung tissues. To introduce other 3D specific function buttons. Layout selection. We can switch between 1x3 and 2x2 layout according to our needs. Generally, we choose the default 1x3 layout. When we need to die or edit on the axial, sagittal and coronal images, we can switch to 2x2 layout. Display orientation setting. This refers to the VIA body position orientation. Click the corresponding orientation button to switch the image orientation of the VIA window. Display mode setting. We can switch between VIA AIP, MIP and MINIP. The cut functions from left to right are cut, undo cut, reset cut. We can choose to cut inside or cut outside. Undo cut can undo one or a few steps of cut. Click Reset Cut button to restore before cutting. To cut unwanted bone tissues, click the Cut button. Drag the left mouse button around the bone tissues to be cut. Release the left button to complete the cut operation. Repeat the same steps to remove other excess bone tissue. Try to select the tangent position for the cutting operations. The operation of undo cut is the same. Drag the left mouse button around the bone tissue that needs to be undo cut. Release the left button to complete the undo cut operation. The cut tissue is then recovered. Remove table. Click to automatically extract the scan table. This function is only for the images of the supine position. Other body positions should remove the table manually. Remove bone. In the threshold input box, we can manually enter the lower and upper thresholds for bone removal according to the real situation. The default setting for the lower limit is 200 Hu, and the upper limit is 3071 Hu. Click to select the Remove Bone button, then click on the bone to be removed. To automatically extract the bone tissue, in the tissue list, uncheck the Show column. The extracted bone tissue is no longer displayed. If you want to display only the extracted bone tissue, you can cancel the display of other tissues. Under the Remove Bone function there is the tissue list. In the upper left corner of the tissue list, there are the Add and Delete buttons. We can use these two buttons to add a new tissue or delete selected tissue. The Delete function can only delete newly added tissue. The three predefined tissues body, bone, couch cannot be deleted. Click the Add button. Name the newly added tissue in the pop-up box. Select the tissue type and the rendering color on the 2D image. And click the OK button to add the new tissue. In the upper right corner of the tissue list, there are the protocol and opacity buttons. We can change the color, rendering and transparency of the selected tissue. Click the opacity button. Drag the slider in the pop-up box to adjust the VIA image transparency. Single-click the OK button to complete the adjustment. Click the protocol button, and select the corresponding tissue in the tissue drop-down menu, such as bone, lung, etc. To display the bone or lungs, double-click the selected protocol, and click Apply to implement the protocol switch. If we are not satisfied with the display effect of the opacity display protocol in the list, we can use this plus icon to add a new opacity display protocol. Click on the Add icon. An opacity parameter adjustment dialog box pops up. The displayed parameters are the same as the currently selected opacity protocol. We can enter a new opacity name. For example, We enter bone 1 and the tissue type is set as bone. The zoom in and zoom out functions can to zoom the displayed curve area, which is convenient for making more detailed adjustments. The numbers displayed on the horizontal axis represent CT values. By moving the curve, we can decide which range of CT values will be displayed on the VIA image. The points on the curve can be used to adjust the opacity. By dragging it up or down, we can adjust the detailed display contents within the CT value. Below the numerical scale of the CT value is a color bar. After double-clicking, we can set the display color of the VIA image. The diffuse reflection adjustment bar below can adjust the display brightness of the VIA image. Slide left to adjust to darker, and slide right to adjust to lighter. The specular reflection adjustment bar can adjust the display effect presented by the high-density tissues. Sliding to the right is stronger, and sliding to the left is weaker. The light intensity adjustment bar can adjust the light beam projected on the image. Sliding to the left is weaker, and sliding to the right is stronger. After we are satisfied with the image, we can click Save. Now the new opacity display protocol we adjusted will be saved in the list. Next time when we need this opacity protocol, we can directly select to use it. There are two methods available for tissue extraction: one-key extraction and manual extraction. One-key extraction. Enter the CT value range and CT value of the extracted tissue, and click the one-key extraction button to extract the tissue of the entered CT value range. Manual extraction. Enter the step as needed. The default value is 50 Hu. Click the manual extract button. On the 2D image, click left mouse button, and simultaneously press the Shift key on keyboard to manually extract the tissue. The extraction is completed. If the internal extraction is incomplete, we can click the Fill Hole button to fill the extraction to make the inside of the tissue fuller. Below the tissue extraction function is the tissue segmentation and modification function area. The functions are erase, dye, add projection, remove projection, add slice, remove slice, magnetic segmentation, expand and erode. Using the above function keys, we can extract tissues or modify the extracted tissues. The commonly used functions are erase, dye, erode and expand. Click the dye button, drag the left button to dye on the MPA image, and the extracted tissue is displayed on the VIA image. Click the erase button, and drag the left button on the MPA image to delete the excess tissues extracted. Click the expand button. The selected tissue will expand outward, become larger and fuller. Click erode button in the drop-down menu. The selected tissue will shrink inward. Send to 3D printing button. Click this button to send the selected tissue to the 3D printing plugin. For 3D printing editing, we can export images in STL format and print directly without editing. All advanced application plugins which support VIA images have this function, and the application scenarios and methods are the same. Undo and reset. The undo function supports returning to the previous operation, and supports a maximum of 7 undo operations. The reset button here is to restore to its initial operating state. In the display content settings, there are the overlay. This button is to set whether the four-corner information should display on the viewports or not. MPA linkage. If this button is selected, the operations of zooming, adjusting W or L on 3 MPA windows will be linked. Crosshair button. This button is to set whether the crosshairs should display on MPA images or not. Box. After selecting, we can adjust on the MPA image to perform the 3-dimensional cut function on the VIA window. Quadrature. If selected, the crosshair can only be moved and rotated orthogonally by 90 degrees. If not selected, the crosshair can be moved and rotated at any angle. Here we will focus on the clinical application of the box function. In our daily clinical applications, we sometimes encounter situations that require partial VIA display, or some structures are more complicated, and the cutting tool will cut wrongly or cut too much by mistake. At this time, we can use the box function to cut the image more accurately and display the required specific structure or position. Let's take the cerebral arteries CTA as an example. After the images are loaded, we can see a complete head via image. For example, now we want to display an image of the circle of Willis combined with the skull. First, click on the box tool. We can see that the rectangular borders appeared on the images. Move the cursor to the borderline that needs to be adjusted. Drag the left mouse button to adjust the currently selected border. After adjusting to a suitable position, click the box tool icon again, and the corresponding borderlines on the image will be cancelled. Since the cutting tool cuts all the outlined tissues, if we need to cut some of the tissues with many tissue combinations, the steps are: first, select the box icon, and then adjust the protection range to be outside of the box, and then select the cutting tool to cut the tissues that are not currently needed. After the cutting is completed, drag the box display border to extend the previously protected range. As you can see, we only cut the tissues within the displayed range of the box. In clinical daily work, we often need to measure the volume of cerebral hemorrhage. The 3D plug-in can quantify the amount of cerebral hemorrhage. Let me demonstrate the operation process. First, we select the patient in the patient management interface. To simplify the operation, we load the 5 mm thickness image sequence into the 3D plug-in. In the MPA viewport on the right, we find the relevant layer where there is a cerebral hemorrhage, and then click the Add button above the tissue list to add a new tissue. In the pop-up box, we name the newly added tissue as bleeding. Select the tissue type. Here, we select soft tissue. We will not change the rendering color on the 2D image. Click the OK button, and then in the tools below we use the Add Slice tool to add layer by layer, using the left mouse button in the MPA view to draw the bleeding area. After finishing, click the right mouse button to end the drawing. We can adjust the drawing in each MPA image to ensure the accuracy of the result. Now we can see that the volume information of the bleeding tissue is displayed as 3.55. This means that the volume occupied by bleeding is 3.55. When browsing via image, sometimes we only need to rotate to the left or right. If we only use the left mouse button to control the rotation, we may accidentally change the orientation of the image. In this case, we can hold down the Control key on the keyboard first, and then use the left mouse button to control the rotation. The image will only be rotated left and right. This will help to avoid rotating up and down by mistake. After achieving our 3D image processing, if we want to save or print the currently processed image, we can click the Tool button. In the pop-up panel, select the Rotation tab, and fill in the angle we want to save. It is recommended to rotate 180 degrees or 360 degrees. Set 12, 24, or 36 images to save, according to the actual needs of viewing via image. Choose left-right rotation or up-down rotation. During rotation, results are also saved simultaneously. We can send images in the database, or send screenshots to the database, or send to the film or send to the video file. The introduction of the 3D plug-in is stopped here. Thank you for watching.